Hello everybody, I am glad to see you again on my channel, and today we'll check a new exercise which is called construct binary tree from pre-order in order arrays. This exercise is of type medium, and now let's check the condition. So the condition says that we will need to design a method that builds a unique binary tree given to integer arrays representing its preorder and in-order traversal such that the preorder tells us that the sequence of the root nodes, which are going from root then to left then to right, but in order tells us the spatial boundary between left and right subtrees, which are coming from left, root, right. So we will need to create a method buildtree, which will have two arguments, preorder list and in-order list. And we will need to return the root node of the constructed tree. So now let me try to explain it in my own words. So the idea is that we have two lists, preorder list and in-order list. And the idea is that somehow from these lists we will need to create data structures, so we will need to create a tree. And now first of all let's check what in general means this preorder and in order. So preorder traversal is when we are starting from the root, then we traverse the left side, and only after that we traverse to the right side. So let's check. So we start from the root, we traverse the left side. Because we haven't finished to traverse the left side, we still continue to traverse the left side, so we are going to 4. And now when we've reached the end of the tree, we go back to the root and start to traverse the right side. From that root we are going to the left, and that's the idea. So where we will finish to process the left side of the initial root, from there we have started. It means that we already traversed the left side, so we continue to traverse the right side. So that's the main idea of how we traverse in a preorder order. And now let's check the in order, how in order is working. So actually it's like opposite of preorder, because when we traverse from in preorder, we start from the top and we are going to the bottom. But when we are traversing in order, we start from the bottom and go to the top. So what's the idea? The idea is that we initially need to traverse the left side, all left sides, then go to the root and then go to the right. So let me show you. So we start from the left side, from the bottom. We are going to the root, and now we are not going to the root because we haven't traversed here. We haven't traversed the left side of this subtree, so we are going to the 7, and we are going to the root. Now, because we already processed this side, so which means that we already traversed all left side of the initial root, we are going to the root. So we have 4, 2, 7, 5, 1. We are going to the root, and now we start again from the left side of the right side. So 8, 6, and 3. So that's the idea. And now we need to understand in general how this information will help us to form a tree in the correct order and correct positions. So the idea is that we will need to use preorder list just for creating nodes. So for example, we will start to create nodes with value 1, then we will start to create a node with value 2, then with value 4, and so on. So we will create nodes sequentially with values which are in this list. And then you can ask me in general, then why do we need this in order list? If we can create preordered list and to create nodes. But the idea is that we can start to create for example node with value 1, then we will start to create a node with value 2, but we don't know actually where do we need to place this node, in the left side or maybe in the right side. We don't know that. We don't have this information in our preordered list. And that's why we need to use this in order list, because if you pay attention, you can see that, for example, we start with node 1, this one, and then we are searching in order list this value. So we have found this value, and now we start to create a node with value 2, and we need to understand where to place it. So we check where this value 2 is placed. Is it placed in the right side, or in the left side from this value? And you can notice that 2 is placed in the left side, which means for 1 it will be placed in the left side. So the idea of this in order list is that we can search for a value, for example for 8, and all elements which are placed in the left are positioned in the left side, and all elements which are in the right side are placed in the right side. So that's the main idea, and all the information which you need to know in order to understand the algorithm and how it will work. And now let's proceed and try to implement this algorithm in Java. So let's go here. I've already prepared the structure for the node, and I've also created a signature for our method. Here you can notice that we will return the tree node, which is a node. Yeah, so we will return our root when we will finish the process. And also we have two arguments. The first argument is for pre-order list, and another is for in-order list. Perfect. And now first thing which I want to do, actually not inside the method, I want to create global variables. The first variable will be pre-order index. And why do I need this pre-order index? Because I want to keep globally the value of the index which I need to process. So for example, initially it will be 0, then I will increment it to 1, it will be 1, then to 2, and so on. Why do I need that? Because, how I've already mentioned here, we will create nodes from this list. So initially it will be 0 index, so value 1, then index 1 with value 2, and so on. That's why I need this global index. So let's create this one. Private int preorder index. Initially it will be equal to 0, and also I want to create a map for our in order indexes. Why so? Because I don't want to iterate every time from this list. I just want to create a map where I will store the value and the index of this value, and this will help me a little bit to increase the performance, because when we iterate through the list, the time complexity is O(n), but if I will use map, the time complexity will be 1, because we will extract the value from the map, and the complexity for that operation is O1. So let's create this map. So the key will be our value and value index. Okay, perfect. Now we can proceed, and let's start to implement our method. So let's declare here our variable again, and also let's initialize our map in order index map, which is equal to new map hashmap. Okay. And now let's create a for loop, because I need to put all elements from the in order list inside my map. So let's create this for. Okay, and let's now put all elements inside this map. And that's it. Okay, perfect. Now I want to create a private method. It will be internal method which I will use inside this build tree. And this method I will call recursively. And now you will see what I will do in that method. So let's, I've already mentioned it will be a private method. It will return a tree node. Let's call it array to tree. Here the first argument will be my preorder list. And also I will have two arguments here. It will be left and right. What does it mean? So I will call this method, how I already mentioned, recursively for the left side of the tree and the right side of the tree. And I need to know which elements could be in the left side and which elements could be in the right side. And for that I will need to define something like a diapason, which will represent the indexes. And for that I will need to create this variable. So for example, if we talk about 1, yes, the diapason for that root, yeah, so will be first element, yeah, and the last element, something like that. So let's create these arguments. Okay, perfect. Now, like always, when we talk about recursion, we need to understand when to stop this recursion. And in my case, the condition will be that while left is actually when left will be greater than right, then in that case I need to stop the recursion. Why? Because if left will become greater than right, it means that I already traversed all the elements and I can stop the recursion because I don't have any elements to process. So let's do that. Let's put here left is greater than right, and let's return null. Okay, perfect. And now let's start to create our node. Let's use our preorder list, and let's use our global variable, this one, preorder index ++. Yeah, just increment it here, and we will need a variable where we will store this first element, yeah, in first iteration. Okay, and now let's create a node for that value. Okay, now I need to understand, for example, for 1, I need to understand the index for that element, because I need again to call this method recursively for the left side for that element and for the right side of that element, yeah. And I need to know which elements for 1 are in the left side and which elements are in the right side. For that, I will define a diapason from the first element from this in order list to 5, yeah, in our case, and in the right side will be elements from the 8 to the last element of this list. So I will need to define this diapason, and for that I need to understand which index is for this value 1 in order list. So let's do that. And for that we will use our map. Why map again? Because we don't need to iterate again for our in order list. We just put all elements in our map. It will increase the performance, which will be O1. Time complexity will be O1. So let's use our map and let's search this element in this map and let's get the index of that element. So we received the index for that element, and now we can call this method recursively for right side and left side of this node. I will copy this. And in the end, let's return our root. Or not. Okay, perfect. So this method is ready, and now we can call this method inside this method buildtree. So let's do that. 3. So the initial diapason will be from 0 and the last element. And that's it, almost, that's it. Actually, this should not be here, but here. And now it's correct. So that's the idea, that's the solution. I hope it was clear. If again you have any questions, please write them in the comments. But now let's check the complexity. So the time complexity for that algorithm will be ON, and the space complexity also will be ON. And in the end, I would like to congratulate you, because in the last 8 tasks we have focused heavily on binary tree operations. I hope now for you it's clear what does it mean, what binary tree data structure means, how you can do some operations in this structure, how you can go through elements, how you can go and search elements in deep or in wait. So I hope this was useful for you, and we will see you in next videos. Bye.